Okay, good morning. Today we are going to continue our lesson with intermolecular forces 4.4. These are the learning outcomes. Intermolecular forces are attractive forces between the molecules. Intermolecular forces are responsible for the physical properties such as boiling point, melting point, and solubility of molecular compounds. So these are the classification of intermolecular forces. We have two types of intermolecular forces. One is called van der Waals forces. The other one is hydrogen bond. Under van der Waals forces, we have dipole-dipole interactions and London forces. So first we look at van der Waals forces, forces that act between covalent molecules. There are two types of van der Waals forces, dipole-dipole interactions, the intermolecular attraction between oppositely charged poles of nearby polar molecules, or London forces, the intermolecular attraction between molecules as a result of instantaneous polarization of the electron clouds. Okay, dipole-dipole interaction, or also known as permanent dipole forces, exist between polar covalent molecules. Polar molecules have permanent dipole due to uneven electron distribution. That means we have to determine the molecule given whether polar or non-polar. If the molecule given is a polar covalent molecule, that means that molecule experiences dipole-dipole interaction. So, for example, we take HCl. As students can see, the hydrogen atom is the positive terminal, while the chlorine atom is the negative terminal. So what happened? The chlorine is more electronegative, thus it has higher electron density. So you can see the electron cloud move towards the chlorine atom because chlorine is more electronegativity. And similarly happen to the neighboring molecule, where the chlorine is more electronegative, thus it attracts the electron clouds to itself. Now students can see there is a dipole-dipole forces exist between chlorine atom of one molecule and hydrogen atom of the neighboring molecule. How does that happen? The partially positive end of the hydrogen atom attracts the partially negative end of the chlorine atom of another molecule. This interaction known as permanent dipole forces or dipole-dipole forces. The electrostatic forces between the permanent positive pole of a molecule and permanent negative pole of an adjacent molecule produces dipole-dipole forces. Molecules with higher polarity, stronger dipole-dipole forces. So, when we determine the polarity of a molecule due to electronegativity, the the molecules which contain higher electronegativity atoms have higher polarity, and that molecule will experiences stronger dipole-dipole forces. Polar molecules experiences dipole-dipole forces as well as London forces. Okay, so London forces or dispersion forces exist between non-polar molecules, results from the temporary or instantaneous polarization of a molecule. The temporary dipole will be attracted to each other, and this attraction known as London forces or dispersion forces. Now we shall look at the formation of London forces. Electrons move randomly. At any instant, electron distribution in one molecule may be unsymmetrical. The end having higher electron density is partially negative, while the other end is partially positive. An instant dipole moment that exists in molecule induces the neighboring molecule to be polar. The attraction exists between the instantaneous dipole and induced dipole is known as London forces. For example, let's say we look at bromine molecule, two similar atom or two similar electronegativity. So electron in a molecule move randomly about the nucleus. This is the electron cloud they're referring to. So the electron cloud move randomly about the nucleus. There is no one atom which attracts the electron cloud because of similar electronegativity between two similar bromine atoms. But at any instant, the electron density might be higher on the one side. So, for example, we have two bromine atoms. Let's say the bromine on the right hand side, the electron cloud is slightly bigger or more electron towards the bromine on the right hand side. Thus, the right hand side bromine forms the negative pole. The left hand side bromine, which has less electron, forms the positive pole. This is known as temporary dipole molecule. Why we call temporary? The existence of the positive, partially positive and partially negative pole is due to the uneven distribution of electron at certain time. It's not permanent, it's just temporarily happens at that time. In another time, it could be the other way. The bromine atom on the left hand side can become the negative pole, while the bromine atom on the right hand side can become the positive pole. It can happen whichever way. This is to depends on which side of the bromine atom has more electron cloud. But this is only temporary. Now, what happened? The temporary dipole molecule, as we can see here, temporary dipole molecule induce the neighboring atom to be partially polar. Or in other words, or simple words, what we can say is the temporary dipole molecule will influence the neighboring atom, sorry, the neighboring molecule to follow like itself. Okay, meaning let's say the temporary dipole, the bromine on the right hand side is partially negative, bromine on the left hand side is partially positive. The neighboring molecule will be induced follow like the temporary dipole molecule, meaning to say the neighboring molecule will also have bromine atom negative on the right hand side and bromine atom positive on the left hand side. Okay, so they induce to be similar actually, and when they induce to be similar, you can see there is an interaction between the bromine on the right hand side, which is partially negative, to the neighboring molecule, bromine on the left hand side, which is partially positive. The interaction between the partially negative bromine of one molecule and partially positive of bromine of another molecule is known as London forces. Bear in mind, this is known as London forces, that is attraction between temporary dipole molecule and instantaneous dipole molecule. As students can see on top here, attraction between instantaneous dipole and induced dipole is known as London forces. Okay, factors that influence the strength of van der Waals forces. The first one is molecular size. Molecules with larger molecular size have stronger van der Waals forces, as they tend to have more electrons involved in the London forces. For example, as we know, nitrogen molecule and chlorine molecule both are non-polar molecule because the atoms are similar, electronegativity is similar, so their ability to form attractive forces is only London forces due to the similar electronegativity. And due to London forces, we have to look at the molecular mass to determine which one will have higher boiling point. Since chlorine's molar mass is drastically higher than nitrogen gas molecular mass, therefore the boiling point is obviously higher. The second factor is polarity. This is normally for the permanent dipole forces or dipole-dipole interaction. So we have to check which one has stronger dipole-dipole attraction due to the polarity or the electronegativity to be more precise. Now, let's say we look at fluorine gas and HCl. So we have to determine the polarity. Obviously, HCl will be more polar. Reason, two different atoms with two different electronegativity, and obviously it forms the permanent dipole forces. And students have to take note here, although the molecular mass is almost similar, do not cannot be compared, uncomparable, but their boiling point is different, clearly different due to polarity. HCl is polar, fluorine is non-polar. That's why HCl have a higher boiling point compared to fluorine. So the conclusion here, we have to compare two things. First, we have to compare the molar mass or molecular size. Normally, this is for the London forces molecules which experiences London forces. For the molecule of different polarity, then we have to determine whether it's polar or non-polar to determine or to find out which one has higher boiling point. If let's say there are two molecules with same polarity, that means both are polar, then we have to go to electronegativity. For example, between HCl and HF, which one will have higher boiling point? Between HCl and HF, which one has higher boiling point? That will be down to the electronegativity of the fluorine and chlorine. Students can find out on this. Okay, next type of intermolecular forces, hydrogen bond.